Good afternoon, everyone. My name is Christy Ford. I'm the account executive at Online Resources and your moderator for today. As a quick reminder, please turn on full screen mode for better viewing of the presentations today. And if you have any questions, let's go ahead and type those in as we go. We may actually answer them as we go through this presentation, and if we don't, we'll get to it at the end. We would like to welcome everyone today to the Deeper Dive, a Model of Excellence. We are going to be discussing Oqton's Geomagic, reverse engineering, and design software products. Here with me today from Online Resources is JD Schomburg. JD is the VP of Operations here at ORI. He's been with the company for the past 9 years and has been part of 3D data collection for a total of 19 years. And we have Cade Hill. Cade is the Director of Engineering Services here. Cade is our resident expert in reverse engineering and GD&T applications. He's been with us for the past 5 years and is a wealth of knowledge.
Thank you.
Thank you both for being here today.
Thanks, Chrissy.
Well, we have been a strategic partner with Geomagic since 2002, making this our 20-year partnership anniversary. With the recent merger of Oqton and Geomagic, JD, do you want to jump in here and tell us a little bit about Oqton and who they are?
Sure. So Oqton, 3D Systems, Geomagic purchased Oqton, but really the power that Oqton had was their AI technologies for manufacturing. So bringing this whole suite of technologies that they already had, plus some additional kind of business and manufacturing process things. So everything's in one place that it can come together in a very organized way and just really bring the benefits of the 3D Systems, Geomagic brands with the Oqton brands. And it really helps connect everything in the manufacturing facility from like the purchasing materials to quality control, things like that.
Wow, love it. So while we're talking about this, it sounds a lot like us. Mm-hmm. For those who may be new to the webinar series, would you just share a tidbit about Online Resources and what we do?
Yeah, so Online Resources, we started in 1991, and we really jumped in with CAM technologies. And we had the vision of quickly spreading to bringing 3D technologies to manufacturing. That was 3D printing, 3D scanning for reverse engineering initially, and then once the technology increased and got more accurate, we brought on quality control in those applications. So we really try and simplify the technologies for manufacturers so they don't have to go through that painful process. And we've even grown into a robotics, what we call AQC, or automated quality control. And then we just this year launched virtual reality, and that's focused more on business applications and technology applications. So we really see ourselves pushing forward, looking for the newest technology, and making sure we vet that technology so that the 3D technologies for manufacturing are simplified.
I love that. Perfect description. Thank you. So we do have a lot to share here today. Let's go ahead and get rolling. For those of you who are interested in learning more, we will put Oqton and Online Resources, those web addresses up there for you. So just so you have those. Cade, let's start with Geomagic's Design X.
Okay.
Tell us what it is.
So Geomagic Design X is a software package that's specifically designed and intended for reverse engineering using high density scan data as your reference. So basically the idea is to take a part that doesn't have any drawings, any CAD models. There isn't any data that can be used to manufacture these parts. Scan them using some high accuracy scanner, and then take that data into Design X so that you can build a CAD model, a 3D CAD model around that scan data. It has many different features. It allows you to query the scan data in different ways. You can perform accuracy analysis, make sure your CAD models are accurate relative to the scan data, things like that. It's quick, easy to use, and doesn't bog down like many other software packages when you use scan data for reverse engineering. So.
Yeah, so I mean, really, scan data years ago was unusable. Mm-hmm. And so Design X is the place where the scan data had a purpose.
Yeah.
And so that's really the powerhouse there, and it's been developed. It's a global leader in reverse engineering applications now.
Yeah.
And so a lot of times I get to hear you in conversations with customers you ask about design intent
Yeah.
or as is.
Right.
What are you asking there?
So there's a few different schools of thought when you're doing a reverse engineering project using the scan data. Different modeling techniques that can be used. One of the biggest questions among several is going to be whether or not you want me to model the part as it is, provide you the data with all of the imperfections sort of built in, any manufacturing imperfections, damage, warping, things like that, or if you want to have the part modeled to what we would consider design intent, which means we, where necessary and where appropriate, make assumptions about the part as it should be, and we override the scan data in those areas to make the part perfectly flat where it needs to be, have hole locations spaced out using, you know, a regular hole spacing, or make things perpendicular and parallel to one another where they need to be, make diameters to be uniformly sized where they ought to be, things like that.
Cool. So take out the manufacturing error.
Yeah,
Put
or
in the original design.
right, manufacturing error or damage. I mean,
Cool.
sometimes like there's, you know, the part's been out in the hot sun, it's cracked or it's been warped or something like that. You can override that as well.
Cool. So I have a part here.
Mm-hmm.
Yeah.
Yeah, jump
Okay.
in. Let's scan it.
So this is a part that I picked up. It's one we just had here in the office. I think it was a NASCAR oil cooler mounting bracket,
Okay.
something like that.
Sure.
So maybe talk a bit with this part,
Mhm.
how you would start to go through that, and I'll scan it and send it over to you.
Yeah, sure. So with this part, should I hold it up, I guess. Basically, it's, I mean, obviously it's been just machined out of a piece of billet. So things, you know, ought to be perfectly square and uniform. You know, this is more than likely a coplanar surface. We can look at those kinds of things on the actual scan data when we get into Design X, but more than likely this is going to be, if I had to guess, like a design intent reverse engineering project. And just, you know, obviously make things square where they ought to be, make angles, you know, nice round numbers where they ought to be, things like that. So, but yeah, I think you've already sent me some scan data here, so I'll go ahead and pull that in.
Yeah, well, I was going to show
say.
kind of how it scans.
Oh, sure.
So while he's doing that, just a quick thought about the scan data itself, or the scanner itself. He's using a Creaform HandyScan Black Elite scanner. This has the blue light laser technology, which is the best on the market at this point. It's going to catch those reflective surfaces that you see. The detail, point to surface detail, is going to be 9/10 of a thousandth of an inch. And this scanner's got 14 of those laser lines crisscrossing each other to capture that data, and you see how quick it went. So, you know, thinking of that, and you know, you've got this great scan data. We come into Design X. From my understanding, this is the most powerful and considered to be the best on the market for 3D reverse engineering. I did ask you to share some features about the software, tips and tricks, and then maybe how we would use them. So I guess, where do you want to start with all of this?
Yeah, so I think I would just show you, I guess, how I would do something like this. Start just building the model and kind of describe what I'm doing as I go along. Once I do some of those examples, I could share just a few tips and tricks that may not be applicable to this specific part, but are good to know in the future for those of you who use the software.
Perfect.
So let me go ahead and have my screen showing here, and I will demonstrate to you the process. So on the screen, you see the part. JD has sent it over to me, thank you. Right now, just like any other scanner, well, any other handheld scanner, the part's going to be kind of floating out here in space. You see that I have my top, front, and right plane intersecting with one another over here, and then we have the part just kind of floating out in space in a seemingly random location over here. The first thing that I like to do is I like to get the part aligned to the origin. And to do that, I'm going to define some datums here that I'll use just to use as locators to get the part to the origin. I'll show you how that works right now. So I think where I'd like to start would be to make a plane perhaps on the back of the part here. To do that, I'm going to use my Smart Selection tool, and grab the entire back of the part here. So this Smart Selection tool is pretty nifty. What it does is it intelligently selects scan surfaces based on either surface curvature, normal direction, things like that. So I clicked on this plane here with a single click and then drag my mouse up while holding the mouse button, and the selection tool becomes more tolerant of changes in normal direction. The same thing would work if I had clicked on this curved surface here. It's going to become more and more tolerant of surface curvature changes, and you see I very quickly and easily selected that cylindrical surface there as well. So to begin, I'll use that tool and select the plane on the back of the part here. And I'm going to do what's called a region group, and I will region group this selected area here. And what region grouping is I'm telling the software, based on the selection that I have, I want you to make your best guess as to what primitive shape that selection is. And if I hover over this shape, you'll see that the software thinks that's a plane. Most likely it is, unless there was some kind of concavity or convexity to it. It could see it as a cylinder or something, but like I said, this is a machined part, just machined out of billet, so this is more than likely going to be nice and flat, and we can go ahead and select a plane on there. So with that selected, I'm going to do a sketch on this plane. So what's really cool with Design X is that it allows you to perform sketches just like you would in any other CAD package, not only from reference planes, like I showed you floating out here in space, these reference planes. It also allows you to define planes on the scan and perform sketches on planes extracted from scan data. So I'll go ahead and select this plane that I've just created, and under my Sketch tab, I will do what's called a mesh sketch. And mesh sketching is something that you're going to see time and time again through the reverse engineering process using Design X. What it is basically you define a plane, you select that plane, you perform a sketch on that plane. But the kicker is that it's not just sketching randomly on the plane. We're actually going to take and sample a cross-section of the scan as an offset from this plane. So you can see as I drag this plane back and forth, that light blue profile is changing relative to where that plane is sectioning the part. So I'll go ahead and drag this plane up some arbitrary amount. The goal here is to grab a circle on the center that I can use to define my origin. I'll also grab the base of the part here that I can use to constrain one of my X axes along, either my X or my Y axis, whichever I choose. So dragging it up 0.7 inches here, I'll go ahead and hit the checkbox.
So you're using this, as you're going through that, you're using this mesh sketch tool to aid in your alignment process before you even start modeling.
Yep. So this is, you could consider this part of the modeling process, I suppose, but really what this is just preliminary to the modeling process. I'm defining a coordinate system on the scan that I can use to move the scan to the world coordinate system.
Okay.
So like I said, I think you could do this several different ways, but for this part, what makes sense to me would be having the origin at the center of the part here, and then having either the X or Y axis constrained along this other face here at the foot of the part.
Okay.
So going normal to this sketch now, I'll go ahead and hide my scan data just so I can see my raster image here. And I'm going to grab my circle tool, and I will just marquee select around this circular area in the center. And you'll see that Design X, once I have that selection performed, will automatically best fit a circle to that preview image. The circle has some characteristics here. You can see its radius is 0.4887. It has a position which is inconsequential to us at this point since the part's floating randomly in space. But once I get this part aligned, this will be XY 0 because this will be the origin of the part. So go ahead and hit the checkbox on this. My next step is to make a line that I can constrain one of my axes to. So I'll go ahead and just define a line, and you can see that it actually snaps to the raster image once I get it close enough. So there's no accidentally clicking this at some random location. It snaps it directly to there. I'll create another line from the center of the circle that is parallel to this line, and then another line that's perpendicular to that one as well. So you can see what I've done here is I've made a circle that defines my origin. I have an X-axis and a Y-axis. The X-axis is parallel to the foot of the part. Okay. So what I'll do now is I'll exit this sketch, and what I want to do is under my model tab create a coordinate system. So creating a coordinate system here. My origin is the center of my circle. Positive x is the end point of this line. Positive y is the end point of this line. You can do xy or xz or whatever you prefer, but just for example purposes, I'll just kind of do this the way I've done it here. The z-axis, however, is pointing. You can see if I zoom in here, it's kind of pointing the opposite direction. I will flip my x, which will flip z. And now you see I have a coordinate system at the center of the part with the axes going in the directions that I've defined. So now, the last step of the alignment before we actually begin the modeling process is going to actually perform the alignment. So I just have the part floating here. I have a coordinate system at the center of the part, but you can see my origin is still way over here. So what I want to do is I want to match my coordinate system I've created at the center of the part to that origin, and you'll watch as the scan data kind of snaps over to that location. So under the alignment tab, I'll choose data match. And it's asking me what scan I want to move. I only have one scan in the workspace here, so it's the only one available to me. Now what I want to do is I want to perform the alignment. So I'll try and get the origin and my coordinate system on the screen here. And you'll watch on the right side of the screen in this window, the part will kind of snap over to the origin once I have these selected. So my datum pairs that I'm matching is going to be coordinate system 1. I'll click that. And then holding the control key on the keyboard, I'll click the origin. And you'll watch as the scan data kind of snaps over to the origin. And now I'm aligned. And my reasoning for doing that is for two main reasons. The first of which is when I'm doing the modeling, when I'm in the modeling process, I want to be able to go normal to these planes and look directly at one side of the part or another. There's nothing stopping you from modeling the part exactly where it is when you bring it in from the scan, but this is extremely beneficial to be able to go normal to these different reference planes and look at the part from perfectly on one side or another. The other reason would be the CAD model, once I finish building it, whatever manufacturing process I send it to, after it's finished in Design X, that CAD model is not going to be floating out randomly in space, right? Like when you bring this into your CAM software to program a toolpath on, you want this to be at the origin right away, so that you don't have to program a toolpath somewhere for you in space, or you don't want your machine. You don't want your machinist to have to realign this. It's just going to be there for him to begin programming on right away.
Cool. Great.
Okay, so let's begin the modeling process. To start, I'm going to get basically the overall shape of the part. And I'll do this just by selecting my front plane. And I want to kind of get the entire silhouette of the part here. So under my sketch tab, I'll do another mesh sketch. Again, this is going to be happening time and time again throughout the reverse engineering process. And I'm going to drag this up some amount just to get kind of the overall profile of the part. If I wanted to be absolutely certain that I was getting the absolute maximum boundary, I can also use what's called a shadow box, which allows me to drag this arrow up. And I have the scan data sort of sitting inside of this volume here. And this is almost like you're shining a flashlight at the part, and
so
you're
like
getting the
for a cast part with draft.
Right. Yep.
You're guaranteed to get the
widest point. That's
cool.
right. So that's what I'm doing here. The reason being is I'm familiar with this part. I do know that there is a manufacturing defect. This is at a slight angle.
Okay.
So I'm just kind of cheating here, but I will illustrate that to you in the color map here in a second.
Cool.
So we will view that together. So with the part looking like this now, go ahead and hide this again. I'm going to sketch out this outer profile. So under my sketch tab, I'll go ahead and do another circle and just double click to best fit a circle. Now, remember, we put the origin at the center of the part here. So design intent would make it so that I should probably put this perfectly on center as well, since these two are probably supposed to be on the origin, perfectly concentric to one another. And notice that I'm actually 1/10 and 2/10 off center, which is actually pretty good. I'm pretty impressed with how precise that is just on the part. But just to make that perfectly 0, 0, I'll go ahead and just make sure that's dead on center. And I'll also, you can make this 1.85 and just drop the 8/10 off the end. Just make that a nice square number.
And again, that's for design intent purposes.
Right, and it's maybe I'm making too many assumptions there, but just to illustrate, you can perform these changes if you need to. I'll go ahead and make a line across the foot and constrain that horizontal. I'll also make a vertical line on either side of this foot here. And I'll make another line straight across, which is perpendicular to the sides. And now I'll trim all this together using a corner trim. Some of these tools I'm going over pretty quickly, but any CAD modeling folks out there will be familiar with these.
Sure. And I've noticed that while you're doing that, it's set up very similar to SolidWorks.
Yeah,
So it's a very friendly environment, you know, with your history tree over there, your modeling tree down below, and then your nice ribbon selection up top.
Yep.
So it seems like it's a pretty quick.
It looks very familiar to many other CAD packages on the market. That's right. All right, so I'm now extruding this up, but I don't know how far to go. So what I can do is I can turn on my accuracy analyzer here, and I can adjust this down.
That's cool. So it's a live feed
until you start seeing. So right now you can see I'm in the green zone here, and this analyzer is set at, I'm just going to set it at 5 thou, say. So I've got my 5 thou on the foot, obviously well within 5 thou on the back, on the side, well within 5 thou everywhere. You can see this is what I was talking about, how it was kind of at an angle. You see how we're at 5 thou here, and then it gets a little bit proud here. So now I'm not at 5 thou here though. I'm proud here, so it is an indication I need to drag this back down. I'm at 1.73 now.
What happens if you go low?
You can see this one. So 1.7, and I'm about maybe 15 or 20 thou shy here. So I'll do 1.715, and that will bring it up to about the correct level. Maybe even go slightly higher. Let's do 1.718. And that'll get me well within 5 thou across the entire surface. Okay, so there's the overall shape done.
Cool.
Let's go ahead and perform some extruded cuts on this. I'm not sure how deep you want me to go into this, but I can just continue going. Just let me know when you want me to stop.
I think just keep going, and
sure.
I mean, I'll kind of ask questions. I don't see any questions coming up yet,
okay.
So I'll ask them.
Sure. All right, so I'll go ahead and perform these two extruded cuts, these 4 windows here. Like I said, I'm assuming these are coplanar. We'll find out here in a second. Once we actually perform the cut, we can adjust accordingly if they're not. But I'm going to go ahead and do another mesh sketch. It's going to be mesh sketches after mesh sketches after mesh sketches, especially with parametric and prismatic parts like this. You're going to be mesh sketching a ton. So let's go ahead and, again, cut these windows. So I'm going to actually convert this entity. The reason why I'm doing that is because when I cut this window, I want the cut to be coplanar with this surface here.
Got it.
And I'm going to make sure, I might even just mirror these over. So I'll just do one side of this. I'll do a line here. Come over here and drag that up to touch off there. I can trim this all together. And I will do a 3 tangent circle on here. Trim this up. Close this off.
I think now you guys can see why Kate is the person we chose to have do this.
Yeah. Maybe I might forget to, I'll get in the zone here and forget to talk about it, but I'm just adding some fillets. I got lucky there. There's a 375 fillet, but if I didn't have 375 set, what you could do, this is kind of cool. Inside of Design X, you can play with fillets by clicking and holding and dragging. You can see you can change the size of the fillet and get it close. And I'm at 3714. I'll just make this a 375. Close this one off as well. And sorry, I have to make that vertical or it's going to bother me. Okay. All right. So now what I'm going to do is I'm going to start from center with a construction line, and I'll mirror these guys across. Again, following our principles here, we want to make sure this is nice and symmetrical. I could have just sketched those out if they wanted me to just build it as it is, but assuming that this is supposed to be a bilaterally symmetrical, I'll go ahead and just make a design line, or excuse me, a construction line here and mirror those across and make it nice and symmetrical. And then I will extrude these down.
Now, if you created a plane on that bottom surface, could you just tell it to go to that plane?
Yes, you could. Yep, and I could have done that as well. Like, for example, if I were to roll this back, and instead of, I'll just put a point, or I can even make a plane. That'd be fine. So, like, if I were to grab this and grab this and grab this and grab this, I'll region group that. Roll this to the end. What I can do is, instead of making this a blind extrusion, I can say up to region, and I can choose either a mean, max, or min distance point.
Okay.
I'll do mean, and then just select that plane, and it will extrude up to that region.
Cool.
Which is pretty nice. You can also have it trim with a region fit surface, which means that it assumes the curvature and shape of that region as well, assuming that it's not too crazy of a shape. Like if you had if that face had a slightly concave shape, I could trim with region fit surface, and it would assume that concave shape automatically.
So you wouldn't have to create that custom surface. Your cutting tool does that for you.
Yep, right.
That's
like
cool.
It automatically assumes the shape, so you wouldn't have to fit a surface and then cut before you did a Boolean operation.
So, being somebody who doesn't know a lot about all of this,
Sure.
I do have a question.
What's up?
You have this scan, you brought it in, you're doing a lot to it. You've got a lot going on there, and you're changing things or whatever. And is there a way to, I guess, set that other scan aside and use a copy of it, or
Yeah.
you know, to make sure that you could always maybe go back to the original scan if need be?
Yep. Now, we haven't done anything destructive to this particular scan yet, but yes, 100%. And that was on my list of things to talk about as well. What you can do is you can copy a scan. Like, let's say a modeling operation that I was going to perform would require me to delete some of the actual scan data away. What you would want to do before you actually delete that scan data is you want to actually make a copy of the scan and perform those direct scan data modifications to that copy. That way you're not destroying any of the original scan. Or if like you made some smoothing, change some smoothing or something like that. The reason being is because Design X does not store any of the direct mesh editing operations in the tree. It only stores the CAD modeling operations. So if I were to come in here and smooth
your framework
mesh,
stays in the model phase.
right, yep. And that's just as simple as copy pasting. So like if I wanted to just, I'll exit this sketch really quick, just hit Control C, Control V. I just made a copy of that mesh, and I don't even touch this mesh anymore. That just sits there, and I just work on a copy. That's pretty good practice, especially if you are deleting faces off of the scan. Like if I just go in here and delete this, for example, so I wanted to get rid of this whole thing. That face on the scan is gone, and you can see I do not have like a delete scan data node in my tree anywhere. So if I continue with my CAD modeling operations and build up 50, 60, 70, 100, 200 operations, I don't have enough undos to go back and get that scan data back if I decide I need it later. So I just make a copy instead, and I know that I always have my raw scan data I can go back to if I decide, oopsie daisy, I messed this up and now I need this scan data back. You know what I mean?
Yeah, that makes sense.
Yep.
I figured there was something like that. I just was.
Yep, 100%. And
I think it was that simple.
Yep. I just and like I said, with this particular scan, I'm not going to be performing any operations that would require me to damage the scan anyway. Maybe on the back here, there's some features back here that I might do some mesh fitting on or something like that. It might be helpful to make a copy of, but for these just 2D sketches and extrusions and things, it's not super critical that you have a copy. But if you're doing like the side of a boat, you've got like fiberglass, like a very highly organic fiberglass shape that you need to sort of extend the edges of, and you just want to surface one side of it or something like that, and you're going to be doing a lot of direct mesh editing, then it would be highly recommended to make a copy for mesh, so you weren't deleting data out of the original.
Nice. Thank you.
Yep. Okay, so I've got just performing more sketches here. I've got this sketch. I'll go ahead and cut away this. Oopsie.
And you just keep going. I'm going to share a little bit more. He's talked about mesh editing. Geomagic also has some other softwares that are just incredible at being able to play with this mesh. One of them is Freeform. So that really is used for like the medical modeling, toy manufacturing, things like that. And it actually changes the scan data into like a clay voxel application, where you can just, with a haptic device or with your mouse, go in and actually model or sculpt the scan data as a ball of clay and push, pull, create new things. So it makes it very easy. Some of the examples we've seen is like a titanium skull plate, where you just kind of mush the clay or the scan data into where that where the bone is missing, and so you take the CT data, then add that, and you can quickly model a perfect fit into the scan data or CT data, and have an exact replica for the patient. So really cool stuff like that. Very specific kind of use cases, but man, when you need it, there's nothing else on the market that can do that kind of stuff.
Right. So just now finishing up the overall outer shape, and then I'll show you some pretty cool wizard tools using fillets and things like that are helpful for estimating fillet sizes. Go ahead and drop this guy in here. I'll also constrain his angle. Make sure this is on 0. Yep. Mirror him over.
Sometimes I feel like he's working in fast forward, like as I'm watching this.
I was just thinking, wow, this is amazing how quickly he's going through this process.
Thank you.
I feel like I know, watching you do this, why this is considered to be such an amazing product on the market.
Right.
Because
it definitely makes things pretty simple to take care of. Speeds up the workflow a lot.
Well, I feel like I've heard a lot of people say like, oh, scanning, like, yeah, it's not good.
Yeah.
Like, we tried that once, it doesn't work. And I felt like saying like, this is the tool you're missing.
Yeah,
like,
it's the missing piece of the puzzle for
Yeah.
a lot of people. Yeah, like if you're just, a lot of people will complain about the scan data that we got from, service provider X, Y, or
Yeah.
Z was cool, but we couldn't really use it. It's like, okay, well, you can't use it because you don't have the right tools to allow you to use it. This is exactly what is needed for most people. So I'm just using a color map here, just taking a look around. I'm missing some pockets on the back, obviously, missing some fillets here and here. You can see that I've actually made this angle bilaterally symmetrical, and you can see that the part actually is not perfectly symmetrical across the center line, which is pretty interesting. This is one of those things, like a conversation starter with the customer, like,
yeah, what do you want?
This is what I'm noticing here. We're about 8 thousandths or so shy if I make this bilaterally symmetrical. Do you want me to kind of split the difference? Do you want me to model it as is? Do you want me to leave it the way that I modeled it? So these are just conversations that you got to have with people.
Or if you're the engineer, it's a quick internal conversation.
Right, exactly, yep. But I'm going to go ahead and put some fillets on this. This is where Design X is pretty cool. This is one of the convenient estimator tools amongst many inside of Design X, but this is one of the most commonly used ones. Under the fillet tool, if I just go ahead and grab one of these fillets here, you can see that it's way too large now. But Design X has this nifty little estimator, which allows the software to estimate the proper size based on the mesh curvature. You can see that I'm not sure it's done the best job, but we can get that to fit a little bit closer by using our accuracy analyzer. So you can see I'm maybe 10 thou Let's try like 0.25. And you can see 0.25 is much, much closer. Yeah, probably just going to do a 1/4 inch actually. 1/4 inch, 1/4 inch, 1/4 inch. And then here,
Wow.
1/4 inch is going to be a little bit too small. And you can see as I hover my mouse over, it's actually giving me a real-time deviation, so about a thou. About a thou. Okay, so there is the outside surfaces of the part done.
And it looks like we do have a question. We could wait till the end, but
Yeah, so now I'm happy.
sure. So it looks like the difficulty of, so like how hard is this system like training wise to get up and running with?
If somebody purchases Design X, normally we would recommend like a 2-day training course. If they get a ScanRAN Design X, we would recommend maybe 3 days depending on the scanner. I'd probably say for scanner plus Design X, you could probably get somebody up and running in like a 3-day basic training
Okay.
course. Yeah. Cool. So I've just made a copy of the scan. The reason for that is because I might need to do some kind of special surfacing operation here. I don't think I will. Maybe. I'm just going to just in case. I don't know yet. So we'll figure that out together. So I'm going to go ahead and just delete some of this data. I'll go ahead and just actually select this plane again. And I will grow this selection a little bit, maybe a couple times. Do the same thing here. Got a couple more areas here.
So and right now you're just trying to separate the areas out.
Yep. Like this.
Cool.
So there you go. So I've just separated these areas. Again, I might not need to do this, but I just want to just have it there just in case. What I'm going to try first is I'm going to try and fit a prismatic entity to this. And actually, let me do this instead. So I've got my planes here intersecting one another down the center of the part. I'll go ahead and intersect these to make a vector. And I'll just perform a sketch on my right plane. And I'll try to perform an axis of revolution, or surface of revolution. Best fit a circle. And I will revolve a torus around this, or a donut. As long as it doesn't crash my computer. Bear with me. Okay.
So again, if you guys have any questions, go ahead, feel free to put those in. I don't know if we'll have a lot of time at the end for questions, so feel free to put those in now and we'll get to them as they come up.
Okay, so trying to get it to cut. Here we go, sweet. All right, let's check and see how close that is. Yeah, really close. Okay, so I didn't need to do a surfacing operation like I thought I might. I actually may need to on these guys here. We will see. Let's go ahead and select these.
And Christy, I haven't been keeping, I want to make sure we stay in the hour. Are we getting close?
We are getting close.
Okay.
We've got about 10 minutes.
Okay, cool.
No pressure.
I'll try. We'll see. Let's try and get this modeled here. So I'll go ahead and try and mesh fit this. I'm not optimistic about this. We'll see.
So So right now you're just making a custom surface that then you can use as your cutting tool.
Yeah, trying to. This may be, these freeform surfaces might be a little bit tougher. I'll actually try and do toruses. Let me try and best fit a torus to these. I don't think they are, because they look like they've got pretty high walls, but we'll see. I'm going to do a wizard here and try and best fit a torus to this. So this is just the same thing as I did with that plane earlier, except I'm doing it with a different shape, basically.
Okay.
Just kind of best fitting a shape to this. And I'll Boolean cut this just to test it out before I do two of them. And it looks kind of close, but doesn't look totally correct.
So one of the things that I know we aren't going to have a lot of time to get into, or any maybe, is really the custom surface. So like for curve surfacing,
Yeah,
things like
sure.
that.
I can try and show that quickly now.
Okay.
That's probably what's going to need to happen with these shapes. So what I'm going to do is I'm going to segment this even further. I'll make yet another copy of this particular mesh. And I don't like it when it makes these dark colored meshes. I'm going to change this.
That's
to a
nice.
color.
You can go into the properties and do that pretty quick.
It's just hard to see when it's that dark. So what I'm going to do is I'm going to break this down even further by selecting just these little hot dog shapes inside of here.
Not sure I would have thought of that.
Okay. And I'm going to invert this and delete. And what I'm going to do now is fill this hole. By using some bridges. So fill hole. Where did it go? There it is. Thank you.
You getting nervous now with time?
No, never. I was hoping that I could have this whole thing done, but not fast enough.
We've been interrupting you with.
Yeah, that's true.
Yeah, I'll blame it on that.
Blame it on me.
Blaming it on whoever. And I'll just fill this hole with like a tangent. And I don't really care what the shape of this is. It's probably not very accurate, but that's okay. The reason why I'm not super concerned about it is because I'm going to be doing a extruded cut through there anyway. So it doesn't really bother me how accurate this is, to be honest. It will be cut anyway. And actually, I might need to change that there. But in the interest of time, I want to show you how this works. The other thing I'll need to do is edit the boundaries of this and just kind of extrude these boundaries up a little bit. In many cases, it's easier to do it this way than it is to do on the CAD model. Just doing it on the scan directly. I can even smooth that boundary a little bit before I do that. It might even look a little bit better.
Cool, so while he's doing that, we talked a little bit about freeform. Geomagic also has another product called Wrap. And this is more of your, when you just need a quick, what I call like an auto surface kind of deal. It's very good to go from scan data to a CAD model with a one button click. So we won't have a lot of time to dig into that, but when you do need those exact mesh surfaces, you can do some macro editing for repeat, so just dumping in and batch processing things. It's a really good tool for those kind of things. So,
And that's the one that takes like an STL, and you can change that STL and make it into a 3D polygon mesh, right?
yeah.
Okay.
So yeah, you take your STL and then export a step parasolid. Kind of you choose. And that's the beauty of these softwares. There's so many times, especially with Design X, where I just need it to transfer into another file type or whatnot, and it's just a good, trusted software to do those kind of things.
Right. So what I'm doing now, like JD had mentioned, is creating some freeform surfacing. It's a little bit more of a time-consuming process, but for these highly organic shapes, if you cannot find a way to recreate them prismatically, what you can do instead is you can organically surface them. So what I'm doing now is I'm just drawing splines on the surface of the part. The first one will be up here at the boundary. I can draw maybe another one a little bit lower. And I hope the spline is visible here. I know it's a orange spline on a yellow background, so it might not be that easy to see. I'm just trying to get this done as quickly as possible here. Draw a couple more. And really what the goal here is to kind of have these set on either side of these contours, and I'll just do one last one here. But I'll actually make these hard edged, because what we want to do is we want to make what's called a four-curve surface model. And by four-curve I mean each of these splines is a four-sided patch. So now I can come over here, draw a line up like this, like this.
Got it. Yeah.
Like this. Yep. And normally I'd spend a little bit more time getting these to be nice uniform patches, but like I said, in the interest of time, go in section, choop, 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 like so. And I'll split these at their intersection points to create a network of four-sided patches all the way around. And then what I can do is I can tell the software, okay, what I want you to do is fill this four-curve surface patch, this four-curve spline network with some surface patches.
Cool.
And it will calculate for a little while.
So, and
Do it.
the Geomagic softwares, those are all products that we sell here at Online Resources. We are also a national training center for all of those, and we have our own tech support. If you're lucky enough, you get paid for that.
Yeah.
But it's really a way that we see the added value that we bring to our customers, where we know exactly what you guys are trying to go after, and we like to take that extra time to help get you there. So I usually say, if you're banging your head against a wall for more than 10 minutes, stop, give us a call, because we could probably solve it in less time. So
Absolutely. I think that, you know, as we looked at these products today, particularly at Design X, like I'm blown away with the simplicity and ease of use for this, as well as the intuitive workflow. It seems to, have a nice ease through that process. And looking at that is just, really impressive, and really, truly, I look at it and go, I understand why this would be the best on the market for things, like this, especially in the design area of things. And I love these color maps.
yeah, that feedback and that color map is, that's critical in your design.
Oh yeah, for sure. Yep, 100%. Yeah, it's everything. I mean, at a certain level, sometimes it's easy just to kind of, in Design X, just kind of eyeball something and kind of just look at the color map, make sure that everything's following within a tolerance that's acceptable. It makes things really, really quick and easy and simple to do. Just trying to get this to behave a little bit better, but the shape looks pretty good. So let me go over
It looks like we have another question.
Sure.
So they're asking if this is compatible with all scan data stuff.
Yep.
So
yep, it will accept many generic scan data file types. STLs, OBJs, point clouds of all sorts, things like that. So you can scan with
we do prefer to use the best handheld systems on the market.
Yeah. A little shameless plug.
Well, okay, but to be honest, not everybody's going to need those kind of tolerances. tolerances.
Yeah.
And there are other, opportunities on the market, even within the Creaform family, that
Yeah.
might not be a HandyScan Black Elite with that kind of, accuracy and resolution. So,
Yeah, that new one so I'm going to talk about
go
it.
for it.
Okay, so we just got it's called the Peel Scanner, the Peel 3, and we've been able to put that through the testing phases here in the office the past week, and I will say it was I was underneath a Porsche. It was up on the lift, a 911, and just wanted to get a real quick underbody scan, and I mean it didn't take more than a minute.
no.
I mean, I'm scanning this kind of baffled. So for the price point, the data quality, the speed, the tracking, and it has full color.
Yeah. Which is huge.
Yeah, I was very impressed.
Yeah. And again, that would be a scanner for somebody that doesn't need these kinds of tolerances. Maybe an artist or a sculptor or something like that.
Yeah.
Those kinds of things. So, we are running out of time, unfortunately. So I hope that we answered your questions today. I hope that you got something out of this. Kate, I really want to thank you for this presentation.
Of course.
That was, very informative and showed us a lot of different ways to use the software. I really appreciate that. If you do have any questions, don't hesitate to contact me. I can get you to the right person if I can't get you the answer. You can reach me at Christy, Kristy, at onlineresourcesinc.com, or you can reach me at the office at 765-482-9700. Again, thank you both for being here.
Of course,
Very much
yeah, no
appreciate
problem.
that and your time. And we hope you have a great afternoon.